All right. All right, guys. So in this lecture, we are going to actually learn about, we've been learning about matters, right? And then once we learn about the matters, we start learning about the subatomic particles, proton, electrons. And then we learn about periodic table, how they're going to have a charge and things like that, right? And so today we are going to actually start making some reactions, right? So we are going to see how these elements are going to be reacting. And then whenever we have a compound, right, whenever we have a new compound, how we are going to be naming it, right? Obviously, right, hydrogen and oxygen, whenever they mix up, whenever they make water, we don't call it hydrogen and oxygen, right? We give it a new name, right? So we're going to actually talk about that. And also we're going to learn about how to write a formula of those compounds, okay? Right, so when it comes to naming, uh, we're going to actually look at in three ways. And if you can remember, if you look at the periodic table, right, we grouped the periodic table according to, we classify the periodic table, right? We classify the elements in three ways, right? We said that this is the stairways that I need to look at it. And if you are on the right side of this stairways, what are you? Are you a metal or non-metal? If you're on
Non-metal.
this non-metal, right? You are non-metal. And if you are on the left side, you are a metal, right? And
Yes.
right here, this is the metalloid stairways. If you are silicon or germanium or arsenic, you are a metalloid. So we are going to look at this again in two different ways, right? So the first one is, again, if you are non-metal to non-metal. Imagine two non-metal atoms are coming together and making a compound, right? So let's say the first one is carbon and the second one is oxygen, okay? So whenever we are doing this, right, obviously we are not just calling carbon oxygen, right? Because if you look at the first one is carbon, the second one is oxygen. So how we are going to name it? So this is how we are going to name it if you have a non-metal to non-metal. So the first one is always preserve the name, and C is carbon, right? This is carbon. And in the second one, we are going to actually treat it as an ion, okay? And remember what was the ion? Ion is actually a charged molecule, right? And the second one is going to be always anion, by the way, okay? And when it comes to charged molecule, right, we are not going to be calling, like, if it's just a fluorine, it's going to be fluorine, right? However, whenever it's charged, meaning that if it's a negative one charge, we are going to add actually IDE, okay? So if I can give you the example of like fluorine, for instance, right? So this is fluorine, okay? So we are going to actually drop the last three and we're going to make fluoride, right? So this is how we are going to be writing, right? So it's not going to be fluorine anymore. Whenever it's tracked, it's going to become fluoride. Make sense? If it's chlorine, for instance, it's going to become chloride. If it's bromine, it's going to become bromide, okay? And same thing with the oxygen and sulfur, right? We are going to still add I. However, we are going to be dropping from the, if I can give you the oxygen, for instance, oxygen. Right now, oxygen becomes, I'm going to drop these four letters, right? And it's going to become oxide. Make sense? And if it's sulfur, for instance, it's going to become sulfide. All right? And the same thing goes with the nitrogen. So these IDE, right, we are going to be using for these three of them, okay? So let's say like that. So we're going to put ID, right? So it's going to be fluoride, oxide, nitride, okay? And phosphide, sulfide. Makes sense, right? And so now I have my non-metal to non-metal, and the first element is carbon, and so the second one is oxygen. Now I have to say not oxygen, but now it's an anion, so therefore I need to say carbon oxide. Now I'm not finished yet, because now I have actually, when it comes to second element, right, you have two of them. So you need to actually tell me how many of them. So you can just say carbon 2 oxide, but we don't usually use those modern letters. Instead, we use the Latin prefix for 2, okay? So for Latin prefix for 2, we use di, right? So it's going to be carbon dioxide. Make sense? Okay. And so let me give you another example. CO. So how would you name this?
CO's carbon monoxide.
Carbon monoxide, right? So here's the trick. Very good. You got it right. Carbon monoxide, right? So for the second one, even if you have only one, right, we actually naming as mono. Okay, right? If it's 2, we are saying di. If it's tri, if it's 3, we are saying tri. But for the first one, as you can see, if it's only one atom, we don't really say mono, okay? We don't say mono. You can just skip, okay? And we assume that it's going to be only one. However, if you have more than one element in the first one, and if I can give you the example of this guy, P2O5, now, right, you have more than one element for the first one, more than one atom for the first one. So therefore, you need to tell me how many atoms or elements do you have in the first one too. Make sense? So how would you name this?
Phosphorus.
Yeah, but we have a 2 over there. Phosphoride?
Yeah. So this is the first one is again phosphorus, right? And first one I'm gonna be calling as phosphorus. I don't need to call it phosphide because the first one is not an ion. Okay, just like the carbon. I didn't call it carbide, right? It's carbon, still carbon. So the first one is, I know it's hard to read, probably you don't see it, but it's phosphorus, right? So you don't have to tell, you don't have to change the first one as far as the element concerned, the name concerned. So it is still phosphorus. Let me see if I get it right. Phosphorus, yeah. And so all I'm saying here is you need to actually tell me how many phosphorus we have. So therefore you need to tell me di phosphorus. And then the second one is going to be, what's the name?
Oxygen, oxide.
Oxide, right? And how many do you have? You have 5. And for the Latin prefix for 5 is, anybody?
Pent.
Huh?
Pen, P-E-N?
Penta.
Yeah, penta.
Yeah, maybe I can write it down somewhere here. So it's going to be penta. We are going to see this penta, hepta in organic chemistry too. It's going to be penta oxide. Okay. So if you have one, right? If you have one mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta. Hopefully you can read it, right? My writing is, yeah, 7 is going to be enough, I guess, more than enough. Okay, makes sense, right? So if it's a non-metal to non-metal, so you need to look at your compound and you recognize whether it's a metal or non-metal. And if it's a non-metal, then that's the naming, how we're going to name actually our compound. Okay, so let's go back to our slide again. So if you look at this one, for instance, now I have, see, N2 oxygen, right? So it's still, the first one, I'm gonna still call it as nitrogen. See, I'm not changing it. I'm not changing it to nitride. Still the nitrogen, but since you have two of them, then you're gonna call dinitrogen. And for the second one, even if you have only one, you are still saying monooxide. Okay, you don't just say dinitrogen oxide. Makes sense, right? And here's the other one with a lot of oxygen. Again, the first one is chlorine, and you don't change the name of the chlorine if it's in the first place, right? And if it's in the second, you change it because now it becomes an anion. And so you tell me how many do you have? You have two chlorine.
Chlorine.
Yep, dichlorine, and then you come to oxygen, and how many do you have? You have 7 of them. And the prefix for the 7 is, we already learned, it's hepta. And now oxygen becomes an oxide, right? Because it's an ion now, anion. Make sense?
Yes.
Yep.
All right, very good.
Hold on.
Sure. I'm here. Don't
So
worry.
this formula where we add the prefixes mono, di, tri, penta. Are we naming metals and non-metals?
No, it is still. Do you think the chlorine is metal, Carlos?
No. That's why I'm asking, because dichlorohepa oxide is 2 non-metals.
Exactly. So we are actually, again, I'm just showing you how to name non-metal to non-metal, because it's going to be different from metal to metal, metal to non-metal. Okay, there may be some differences.
Okay, all right.
All right. Okay, very good, guys. So let's move on. And again, these are some other examples that we just talked about it, right? Carbon dioxide, carbon monoxide, diphosphorus pentaoxide. You know, you have the name. Okay, so now we're going to actually move. Again, these are non-metal to non-metal. In other words, I forgot to mention, right? If you have a non-metal to non-metal, what kind of bond do you have? Do you have ionic bond or covalent bond?
Covalent.
Covalent, right? Because they are sharing, right? They are poor of electrons, so therefore it's a covalent bond, right? So let's take a look at how things are gonna play out whenever you have, now it's Carlos questions, right? If you have metal to non-metal. If you have metal to non-metal, what kind of bond do you have?
Should be ionic.
Ionic, right? Very good. Now, because they are not sharing, they are actually donating, ionic bond. Okay, so how we are gonna name metal to non-metal, right? So yeah, let's talk about the naming first, right? Oops, where's my whiteboard? Oh, here. Okay, so let's take a look at the, the simplest example, okay, that we've seen over and over again, right? So let's say you have a sodium and then chlorine, okay? So when it comes to writing, right, when it comes to writing metal to non-metal, the rule is pretty much the same, okay? There's just slight differences. So far, the rules that you learn from non-metal to non-metal, how would you name this? The first element.
Sodium chloride.
Yep. The first metal is your cation, right? And the cation doesn't change. Again, here the first one is sodium, so therefore I'm going to keep as it is, sodium. And then you're just going to tell me what's the next one. This is chlorine, but it's a chloride, right? Now you just have to tell me the name of the second ion, okay? Okay, very good. But what happens if you have this guy? Let's say you have now you have 2 chlorine. What do you do?
You still have to use a prefix. So
Okay,
it'll
so
be
now the first one is again, the metal is, what's the Mg?
magnesium.
Magnesium, very good. Magnesium. Magnesium. I think I misspelled the magnesium, but let's double check. Yeah,
That's close enough for me.
magnesium, yeah. There's no I. Magnesium. And so in the second one now, again, here's the trick, guys, okay? And I'm going to explain why we are actually using this rule. And so now, so far, you should be saying, what's the name? Magnesium? Is it dichloride?
It should be dichloride.
Yeah, right. But again, since we are actually in the metal and non-metal territory, we don't really say magnesium dichloride. We just say magnesium chloride. Okay. And then you might be asking why that's the case. Okay. And here's the reason. Because whenever you have non-metal, whenever you have a metal to non-metal, actually, yeah, we are talking about metal to non-metal, right? It's whenever you say magnesium dichloride, it doesn't really matter, right? Because whenever you told me it's magnesium chloride, I can actually write the formula of this, right? How can I write the formula? Well, here's how can I write. Again, I'm going to be giving sometimes the name of it, and then you're going to write the formula, right? The vice versa. If I say magnesium chloride, you should know what magnesium chloride is. So how can I write magnesium chloride, right? Because whenever it's metal to non-metal, it's a little easier, okay? So you're going to be writing, right? You're going to go and find the magnesium symbol. And if you go to magnesium symbol, what is it? It is magnesium 2, right? Sorry, magnesium, right? The symbol is magnesium. And we learned from the last chapter how many valence electron the magnesium has.
2.
2, right? And so if the magnesium is going to reacting with the chloride, you remember like whenever I draw the sodium and chlorine, do you think the magnesium is going to lose those 2 electrons, right? Or accept
Yes.
6 electrons, right? It's
They're
going
gonna
to lose electrons. And if he lose those 2 electrons, what's the charge of the magnesium is going to be?
This should be positive charge.
Positive what?
2.
Very good. Positive 2. Everybody's following, right? And again, kind of like back to our topic. If it's a metal, right? We told that if it's in the first group, it's going to be always +1 charge, and this is +2 charge. Did I tell you about this? I think I did, right? And so if you come to the here, right, on the halogen side, the non-metal side, it's the opposite. Now the halogen is going to be -1, right? The 7A, the 6A is going to be -2, and 5A is going to be -3, and the carbon you can leave it there, okay? Because it can be +2, 4, it doesn't matter. And the only exception here is group 3. Group 3 is going to be also +3. When it's going to be +3, whenever they are metal, like aluminum, gallium, right? So these are going to be because they are metal, and metals are electron rich, and they need to have plus charges. They cannot have any negative charges. Period. Okay. All right. Good. So now let's go back to chloride. And chloride, I know it's a chlorine, right? It's chlorine, right? And the chlorine is, what's the charge of the chlorine?
Negative.
-1, right?
-1.
Very good. Okay. So now here's the problem, right? So with the sodium chloride, I have space, I guess. See, it's a nice match. You have sodium with +1 charge, and then you have chlorine with -1 charge. And so it's 1-to-1 ratio, right? And whenever you add charges up, right now, right, you don't want to have any extra charge. So +1, -1, it's 0. But over here, as you can see, there's a +2 here and -1 here. And when you add them up, what do you get? You get +1. And nobody wants to have extra burden, right? Extra charge. These charges are extra burden. And at the end of the molecule, right, we want to always have a neutral molecule, okay? So you need to make this molecule happy, okay? How you're going to do that? Well, you need to add, again, there's 2 ways, right? You need to add, right? Since the magnesium is, again, +2, you need to add another chlorine, right? With -1 charges, so that you have 2 chlorine, and their charges is going to add up to, again, -2 here, right? And magnesium is going to have +2, so that overall charges is going to be 0. Make sense? All right. So whenever you're writing the molecular formula, then you need to actually, again, adding 2 chlorine here, right? So that the magnesium is going to be happy. So therefore, you need to be putting actually 2 here. Okay. So these 2 is indicating that you have 2 chlorine with a -1 charge. So therefore, if you multiply this and this, you're going to get -2. Make sense? And when you add them up, the molecule has a 0 charge, no charge at all, and it's happy. Okay. So therefore, you don't really tell me, right? You don't need to tell me how many chloride do you have, right? If you say magnesium dichloride, right? This is a redundant information because I already know it's going to be 2, right? So therefore, in the naming business, we don't like redundancy. Okay, this is a redundant information. Okay, so therefore, you don't really tell how many chloride do you have because you can easily tell. However, in the covalent bond, you cannot tell because those are covalent; they are sharing electrons, right? And it's not a formal charge, right? They don't have like -1 and +1 charges because they are not giving electrons and taking away electrons. So therefore, it's difficult to tell. Okay, but in the metal to non-metal, it's easy. You can tell because if you know their charges, right? You can bring them together and you can tell how many atoms do you have. Does this make sense, everyone?
Yes,
And whenever you are actually doing this, right, another easy way, you need to always double check though, right? You do actually crisscrossing. In the PowerPoint slides, we actually tell you the crisscross, and that's what I mean by crisscross, right? So you do this, right? So you bring this 2, right? Let's pick up blue. But the crisscrossing means this, like you put this 2 over here under chlorine and 1 here under magnesium, right? So 1 is, you don't have to write it as 1. So as you can see now, if you do this math, right, now you don't have any charge, 0 charge. Make sense? Any questions, everyone? All right, very good. Let's go back to our slides. And let's do some examples. Sodium chloride. Yeah, so let's write aluminum sulfide. Can you write the formula of aluminum sulfide? Alu.
Yeah, yeah. So aluminum sulfide.
Sulfide. Okay, let's try to write the formula of aluminum sulfide. Oops. And again, you can have your periodic table, but I'll bring the periodic table here. Why is this going? Okay, aluminum is here. And sulfide is, again, if it's a sulfide, what does that mean? It's a sulfur, right? Right here. So can you write the formula?
Yeah.
should we tell you, Professor?
Say it again.
Should we tell you?
Yeah, you can. If
So it's
you
gonna be Al2 aluminum,
then
and sulfide is gonna be 3.
3. Okay. Yeah, it sounds about right. Yeah. So now, right, as I'm trying to write again aluminum sulfide, right? So you're gonna go and find each symbol. Okay, so aluminum is Al, right?
Yeah.
Let's write it here so that everybody can follow. Okay, so Al. And so whenever Al, aluminum, is gonna be reacting, right? This is a neutral form, and whenever they are reacting, what's the charges of aluminum is gonna be?
+3.
+3, right? So you have to put +3 on top of aluminum. And then now you're going to bring your another pair, which is actually sulfur. And again, sulfur, whenever it reacts, it's going to be, it's not going to be sulfur anymore. It's going to be ide, sulfide. So therefore, it's going to have a charge of
-2.
Yeah, -2. The symbol is S, and the charge is going to be, again, look at here, it's 6A. It means that it's going to have -2. And the easiest way to cancel these charges out is, again, you do crisscrossing, right? You can put these 2 over here and this 3 over here, and then you can eliminate the charges. You don't want to leave the charges once you have the formula. So the aluminum sulfide is going to be this one. So as you can see, you don't say di-aluminum, right? Because you know there must be 2 aluminum. Otherwise, you won't be able to eliminate the charges. So you know there's 2 aluminum, and you know there's tri-sulfide, but you don't say it in metal to non-metal. You just say aluminum sulfide.
So, Professor, we're dropping the charges when we switch them?
Yeah, yeah. And you just have to write it like that, right? You don't want to, I mean, you can leave it, but technically this is the right way, okay?
Okay, thank
Nobody,
you.
like in the scientific papers, like whenever they write aluminum sulfide, they don't leave the charges, okay? You know there's there, but you don't write it, okay? All right, any questions? All right, very good. Let's go back to our slides and let's see where we are. I think I have a couple more examples here. And so here is, again, metals to non-metals, okay? And now I just want to tell you one more thing here, and there is one exception here. Not exception, but there's like a slight difference. Everything is same. Remember, like whenever I was telling you these metals, even though everything on the left is metals, we said that these metals are kind of like exceptional, right? These pink metals. And we call them transition metals, right? And I told you that it's hard to know their charges, even though they might have 5 valence electrons, 6 valence electrons, but these are, again, because they have actually, again, we are not really like covering this in details, but they have actually, because they are large, now, remember the shells that I tell you, right? And they need to have extra orbitals, okay? And they have actually orbitals d orbitals, and because of they have a large orbitals, d orbitals, they can actually do some weird things, right? So they can actually have different charges. Make sense? So for instance, if you look at the iron, right? Iron is, sometimes it can have +2 charges, and sometimes it has +3 charges. So it's really difficult to tell which one is which, right? Unlike like sodium. Sodium is always +1. Magnesium is always +2. There's no exception. But for these guys, there is, okay? So for those reasons, if you have, still we are in metal to non-metal, but if the metal is not transition metals, then you gotta tell me what is the charge, okay? So therefore, for instance, if I wanna give you an example of copper chloride, right? Okay, and so what is the charge of copper chloride here? Can you tell me what's the charge of copper here? Is it +2 or +3 or +1? What is the
2.
copper charge here? Anybody? You just do, again, like, remember, like I do crisscrossing,
Yes,
right?
+3, Professor.
Yeah, you can just do back cross-crossing, right? You can do back, right? You can just do a backward.
So it's gonna be +3.
Plus 3,
No?
+2.
plus 2, right? Again, it's 2. This is 2.
Oh,
Yeah.
oh.
Again, there are two ways, right? You can do either back crisscrossing, right? You can put this 2 back here because this is where it's coming from. And there's a 1 here, right? And the 1 is here. And we know that this is non-metal, so non-metal has to be -1, and copper is +2. This is number one way. This may not give you always the right answer. It will give you the right answer 99%, but there are some exceptions. The other way is, I can show you, right? You know, we want to know what's the copper charge. I'm going to give you an example and you will see why this is the case, right? So I don't know whether it's going to be copper 1 or copper 2, right? We don't know the charges. So how can I find? Well, you can divide this molecule like that, the compound. You know what the chlorine charges is, right? Chlorine is always what?
-1.
-1. No matter what, chlorine, you will never see chlorine with -2. So if you have -1 charges here, how many chlorine do you have here?
2 chlorines.
2. So what is the chlorine's contribution overall in terms of the charge?
-2.
Negative?
-2.
-2, right? Because you have 2 of them. 2 times 1 -1 is -2. So in order to eliminate this -2 so that you can have only 0 charges, what's the copper charges going to be?
Has to be +2.
+2, okay? So now in this molecules, he said, copper is +2, okay? So therefore, whenever we are writing this molecule, we don't say copper chloride, right? We need to tell, we must tell actually, not need, what's the charge of copper. So what's the charge? It's 2, and I use actually Latin numerical order like that. So it's copper 2 chloride, okay? And the reason is again, is this. If you look at this guy, okay, this is again a real molecule, guys, okay? This is a real molecule. This is a real compound, copper 2 chloride, and this is real molecule, copper chloride 2. So what is this? See, if you don't tell me, this is also copper chloride, right? So how I can differentiate these two? You cannot just write copper chloride. If you write copper chloride, then I will be writing this and you will be writing the top one, right? So now let's find out what's the charge of copper here. Okay, so what's the copper? I know that the chlorine is always what? -1, right? Right? So if it's -1, what's the copper charge here?
It should be a +1.
+1, see that? Now it's +1. And again, these are transition metals and you need to get kind of like get used to it, right? They can have different charges for different molecules. So therefore, I should be calling this copper 1 chloride. Otherwise, if you just leave it as copper chloride, you know, there will be a confusion of which copper chloride you're talking about. Okay? All right, any questions? Okay, so let's do some exercise with this one, with transition metals. So let's write F2S3. So what is the name of F2S3? How would you name this?
Iron sulfide.
Okay.
Iron
sul-
3 sulfide.
Iron 3 sulfide.
Yeah, again, right? So far, I know that this is iron. And the second one is sulfide.
Mhm.
Sulfur becomes sulfide, right? But again, I know that if you look at the periodic table, iron is transition metal, right? You need to tell me which iron you're talking about. This is iron 2 or iron 3. So what's the iron charge here?
3.
3. Everybody see that, right? Why that 3 is coming from? Again, you can do
Yes.
back crisscrossing, you know, and so this must be +3. 3, okay?
So it's iron 3.
Iron 3 sulfide. Make sense?
Yes.
Everybody see that, right? Where this 3 is coming from?
Yes.
No? Yes?
Yes.
Yes.
Yes. So
Okay.
what happens to the 2
Yeah. Again,
iron 2? What happens to the iron 2? Do they cancel out?
no, I think yeah, that's a good question, Carlos. Again, these 2 doesn't represent the charge, okay?
Right.
And so if this is confusing, again, you can do the backwards, okay? You can do this one. You can separate these 2, okay? Again, these 2 is telling you how many iron in that molecule. You have 2 iron atom, and you have 3 sulfur atoms. And the reason why is because you know that what's the sulfur charge?
It's a -2.
-2, always, right?
Right.
And so if you look at the sulfur here, how many sulfur, like what's the total contribution? What's
3
the charge of,
sulfurs.
okay, 3, and all of them as -2.
Right.
If you multiply,
And
it's
-6.
6. Very good. So in order to have 0 charges, I need to have how many charges here from the iron?
For iron.
No.
3.
No,
Plus
total
six.
charges.
Oh,
Like,
6.
yeah, 6, right? Plus 6. To cancel out this -6, I need to have +6. And since you have 2 of them, you need to divide that +6 to 2 of them, right? So therefore, iron is going to have 3. Make sense? Plus
Yes.
3. And again, this 3 is, you can do this and then you can double check, but this 3 is, again, you're just back crisscrossing. See that? You are back crisscrossing, and this 3 is right there. Okay? So therefore, you need to put it back iron 3 sulfide. We missed the sulfide. Okay? Makes sense, right?
Yes.
Yeah.
Okay. Good. Okay, so again, iron, this is copper chloride. We talk about, again, this is iron 3 sulfide, and the reason is, again, because it's a transition metal. Okay. And then we have actually compounds called binary compounds, okay? And whenever I say binary compounds, right, we are going to actually treat them, right? If you look at the binary compounds, they are actually have, you know, what we've seen is we've seen all just monoatomic ions, right? But there is going to be some polyatomic ions as well. And so these are going to be actually, let me see. Yeah, if I can. And these are the polyatomic ions that we are interested in. Let me see if I can add the PDF file. Let's see how this is going to turn out. Yeah, I think this is good. Okay, so this is actually a file, and I believe you have this in your Canvas file folder. Okay, and you can see it, right?
Yes.
Let's lock this. Okay, now it's locked. So if I zoom in, and I'll show you, right? So this is the ions that we've seen so far, right? If you have only one of them, right? You don't worry about the hydroid ion. You don't have to worry about this one, okay? So now, if it's only one, we said that it's fluoride, fluorine, bromine, iodine, right? And you don't have to worry about the cyanide here. And the first example of the binary compound is hydroxide, right? So if you have OH, right, it's not just oxygen, it's not hydrogen, but the OH, this whole group is actually having -1 charge, okay? And whenever you have this ion, you're going to call you hydroxide. This is the first one with a -1 charge. For instance, if I give you an example, if you bring like sodium here, right? So sodium has 1 plus 1, and OH is negative 1. And if you add them up, you're getting sodium hydroxide. See, you're going to see the sodium hydroxide in acid and bases. So you are treating this whole thing, right? Even though you have 2, you are treating this whole thing as 1. Okay, and whatever the charge is here, you are applying the same rules that we've seen. Okay, and we already seen with the oxide, right? And you don't have to worry about the peroxide. I'm just crossing this out. The crossing out, like whenever I cross out, you don't have to worry about it. So this is actually 2 oxygen. This is an interesting one. 2 oxygen with negative 2 charges, right? If you have hydrogen peroxide, for instance, hydrogen peroxide is, you can buy it actually on groceries, whenever you have, I use it actually, I use it like yesterday. I have something on my ears and I put it like hydrogen peroxide so that it gets kind of like dry, right? It kind of like,
To clean the
makes it-
wound also.
yeah, it kind of like, it cleans the wound, they antiseptic, I guess. And it's good actually. I like it, Don't drink it, but it's good for your wounds. So this is hydrogen peroxide, you can skip that. And we already seen the sulfite with negative 2, and this is nitrite. So the binary compounds is these guys, okay? So as you can see, we have actually a couple of them, but you don't have to worry about all of them, but we need to worry about this guy here, acetate. This is number 1, important one. You don't have to worry about the chlorate. You don't have to worry about this one. And now you need to worry about these 2, nitrate and permanganate. Not so much of permanganate, but nitrate is important. And carbonate is important. Chromate, dichromate, you can pass. And these 2 are important too. These are like, again, you see phosphate in living organism everywhere. So what happens whenever you have such compound? So I'm just going to give you one example here, right? So if you look at, for instance, let's look at this easy one first. So whenever I say, for instance, sodium sulfate, right? Sodium sulfate. How can I write the formula of sodium sulfate? Okay, now you have the name, and then you want to write the formula. Again, same principles applies, right? You are going to find the symbol of sodium, which is Na. And what's the charge of Na? What's the sodium charge? Periodic table, guys.
+1.
+1, right? Always +1. And then you're going to go to your table again, and you can use this table in the quizzes. I allow you to use it, okay? Because you're, not a chemistry major, right? And you're going to find the sulfate, okay? And what's the symbol of sulfate? You're coming here, and this is SO4, right? And you need to be careful with the charges too. You need to bring the charges with him, okay? So what's the charge? It's -2 here. So you're going to write SO4. Again, this SO4, whenever there's -2 charges, this is important, guys. These -2 charges doesn't belong to oxygen, okay? This -2 doesn't belong to only oxygen, doesn't belong to only sulfur, okay? This belongs to, again, whole molecule, right? SO4. So you're like putting like a parenthesis like that and putting the -2 charges, okay? And you're going to treat this SO4, even though you have 2 diatomic molecule, you're just going to treat it like 1. Doesn't matter, right? If you have only 1, what would you do? Right? You'll do the crisscrossing to eliminate the charges. Now, because you have -2 plus 1, you have -1 extra burden. You don't want extra burden, right? How can you do that? Well, you can either do crisscrossing, the easiest one, right? You can put these 2 here and then 1 here, right? Crisscrossing. And now you have, as you can see, you have 2 plus 1 is +2, 1 plus -2 is -2, and total 0 charge. Make sense? So now you can erase these charges and you can leave the parentheses, it's okay. And so the formula is going to be N2SO4. Make sense? Does this make sense, everyone?
Yes.
Yeah.
Yeah.
Good. All right, so let's write then.
Hold on, Professor. In the column for carbon. How many carbon, silicone? How many
Well-
char is that? 4 negative or 4 positive?
Yeah, don't worry about the carbon.
Okay, so
Yeah, don't worry about the carbon.
okay.
But
So,
here again, the important thing here, right, is sometimes students mixed up, right? Whenever they are writing the polyatomic ions, they start naming this and this. They say sodium sulfide oxide or something. No, because now this is actually 2 atoms, just like the water, right? Whenever you have water, we don't call this hydrogen and oxygen. There's a specific name, okay? So these are the specific name for these polyatomic anions. Make sense? So you don't do that, okay? You don't like try to name sulfur oxide sodium. No, that will be totally wrong. Okay, so let's try to write the name of sodium nitrate. Oops. Anybody?
NaNO3.
Right? So sodium is, we already seen sodium, and it is a +1 charge. And nitrate here is, it's right here, right? Where is it? It's right here, NO3 with -1, right? And nitrate is, by the way, they use actually as a preservative in a lot of foods. You will see, like if you read the ingredients, you will see nitrate. So now I don't have any problem, right? It's 1-to-1 ratio. So it's easy. Yeah, you just have to put 1 and 1 here, right? So you don't have to worry about it. If you just bring them up, it's just going to be again sodium nitrate, like that. Okay.
Mm-hmm.
All right, let's do one more, and I think we're good to go. Let's say, yeah. Okay, let's say aluminum phosphate. Aluminum phosphate. And phosphate is right here.
So it's gonna be AlPO4.
Okay. Sounds about right. Again, let's do it together again. Aluminum is, we know the symbol is Al,
Mm-hmm.
right? And the charge of aluminum is going to be what?
3.
+3, very good. And phosphate, again, I'm bringing the phosphate, which is PO4. And then there's a -3 charges, and you can put the parentheses like that. It's up to you, you know. You don't have to. Okay. And now see, it has, both of them has 3 and 3, right? So it means that whenever you bring them up, even though, right, you can actually, again, do the crisscrossing here, put the 3 here, and put the 3 here, but again, it's 1-to-1 ratio, just like this sodium nitrate, right? So I don't really write like 1 and 1 here, just like that, because it's the same thing, right? 3, 3, they kind of like cancel them each other out, right? You have only 1-to-1 ratio. So therefore, it is really Al, PO4, right? You have 1 of each. This is 1 and this is 1. Does this make sense, everyone?
Yeah.
Right? Okay. So yeah, as long as they cancel out, you know, if they are the same number, you don't have to write, like, you don't have to like this is like good. This is still true, right? AlPO4 3. This is good, but again, this is redundant. Like I don't need to see 3 here. Okay, so therefore you just leave it as AlPO4. Okay, make sense?
Yes, Professor.
All right, good. So again, these are gonna be my what you call it, polyatomic anions, and this one is actually the one on the top is acetate. Does anyone know what the acetate is? Acetate. This is actually, again, we're going to learn about this in acid and base solutions, but I can briefly tell you this is actually the anions of acetic acid. Acetic acid is this guy. When we learn about organic chemistry, we're going to learn about some acids and bases, and this is actually a carboxylic acid. And whenever it gives up this proton, see, right, CH3, COO, this is this guy here, this is acetate plus a proton, right? So this is actually acetic acid. And you know what the acetic acid is?
Vinegar.
There you go, Carlos.
Vinegar.
Vinegar.
Salad dressing.
Yes, I love vinegar, by the way. Okay, so vinegar is, again, the acetate is actually coming from vinegar, right? So whenever you have acetate, it means that you have vinegar, basically. Okay, that's what it is, really. But yeah, there are a lot of compounds, obviously, in chemistry, in organic chemistry or organic chemistry. Right. So again, this is another formula. Arsenate is another one, but yeah. For instance, yeah, these are good example too. See, look at this one, for instance, like sodium. You have 2 of them, right? And then you have oxygen, right? So we are gonna still call this sodium oxide, right? Don't be like, oh, this is like disodium oxide. No, okay? It's gonna be still sodium oxide. Again, we talk about this transition metals, right? Iron 3, iron 2, and etc. This is iron oxide. Yeah, we all. Yeah. And again, this is another one. See, hydroxide. Okay. And and these are again some, when it comes to acid and bases, right? Usually, whenever we want to name this, right? So far, the naming that we learned, we should be calling this like hydrogen chloride, right? This is still true. We can still call hydrogen chloride. But since this is an acid, we kind of like give them a common name. And now instead of calling hydrogen chloride, right, we kind of like drop this "ide" and then we just convert it to hydrochloric acid, and then we add acid. So these are again common acid. That's good to know. And just like this one, right, this is actually we will be calling like hydrogen sulfate, right? And then, but we just look at the sulfate, look at the anion and change it to sulfuric acid, okay? And as with the phosphoric acid, this should be called hydrogen phosphate, but we just change the phosphate to phosphoric acid. See, phosphate to phosphoric, sulfate to sulfuric acid, and then nitrate to nitric acid. This is acetate to acetic acid. This is carbonate to carbonic acid. Okay. So these are actually good to know acids. Obviously, there are thousands. I mean, not thousands, but maybe hundreds of acids. But these are the important ones that we are going to be using actually in this lecture throughout. Okay. All right, guys. Any questions? And I just want to have you one more question before we go. Let's do this question. It just came to me, and then maybe we can give you like a couple more. So if you look at this guy here, this is chromium, oxygen, and let's say there is 2 of them. Okay, how would you name this?
Chromium dioxide.
Where was that thing?
Professor, it's not chromium dioxide.
What's CR stands for?
Chromium.
Chromium, right? Chromium.
Chromium.
Chromium. Do we have that question here somewhere? No, that was actually chromium hydroxide. Okay, so what is it? Chromium oxide? You said?
Di.
I said dioxide.
Okay, what is this chromium? Is it the metal?
Yes.
So if it's a metal to non-metal, how would you name it?
Chromium oxide.
Okay, chromium oxide, right?
Correct.
Okay, like again, the first one is metal, this is metal, and this is non-metal. So you're gonna name it as chromium. The second one is oxide. But look at the periodic table. Where is the chromium? Is it a non-metal? I mean, is a metal? I know that, but
Transition.
it's a transition metal, right?
Mhm.
So you gotta tell me the charge of the chromium.
Oh, so we need the
Chromium is going to have a
numerical.
+2.
What is it? Is it +2 or +4?
+2.
four.
Plus
Four.
two.
+4.
Four. It's four.
Okay. So again,
Oh,
this is
okay.
kind of like tricky, a little bit tricky, but not much so tricky. Again, I told you that the crisscrossing never is gonna work most of the time, but sometimes it may trick you, right? If you back crisscrossing, you will just put 2 here, right? But then if you put 2 here, it means that this oxygen is gonna have -2 charges, and 2 of them is gonna have -2 charges. And I already told you this is a different element actually. This is peroxide, right? So I'm not saying it's a hydrogen chromium peroxide. I'm saying chromium oxide. So therefore, you need to always double check with the regular charges. And how would you do that? You just have to know, right? If it's chromium oxide, right? It means that this oxygen is -2 charges, and then you have 2 of them, correct?
Yes.
And the total contribution of oxygen is -4, right? And in order to eliminate -4, what's the chromium charge is going to be?
Positive 4.
+4. Okay, very good. So
Oh.
therefore, this will be chromium 4. I hope I did the right one with the Latin numeric number. Is it right? Not the
Yeah,
other way
it
around.
is right.
Yeah, I sometimes mix it up.
Okay, I understand now. I understand how you got the -2
Yeah,
plus the O2, 2
Yeah.
oxygens.
yeah, because if you do the crisscrossing right away, then you will think that, oh, this is chromium 2, okay?
Yeah.
But it's not the case, because if you have the chromium 2, then you cannot have a chromium oxide. That's going to be chromium peroxide, okay? That's
Yeah.
going to be a different name. All right? Wow. I'm sleepy, guys. Sorry. All right, I think we did good. Let's stop here for now, okay? And do you feel we can go another chapter, or?
No, that's way too much already.
You think so? Okay, I was planning to go one more chapter, but yeah.
I think whatever for me, being that I've never done a lab, can
Yeah.
you briefly tell us what we're going to expect with the lab?
Oh, for the lab?
Oh, good question.
Yes, because I never did this on a computer.
I see. Yeah, again, it's not the same feeling of doing the lab, but it's pretty much, let me check the labs. Yeah, I don't remember what we were doing. Again, you're not gonna have any lab this week. I'm gonna give you the assignment for next week, right? We're gonna have lab every other week, and so let me check the lab. Which lab are we doing? Yeah, I think I'm gonna hold on to this, guys, because it's actually this is about pHs. So this is about this is about acids and bases, and we didn't cover yet. So what I'm gonna do is, again, sometimes I play with these labs. So we are not gonna do the lab maybe like 2-3 weeks, and then I'm gonna give you the lab and then at that time I might be giving you labs not every other week, but every week. Yeah, so here what you're gonna do is you're gonna go to a simulator again, and so there is this pH meter, and you're gonna be actually looking at the pH of different samples, right? So so you're gonna measure the pH of like soap, blood, spit, water, milk, some juice, like orange juice, some soda, some coffee, right? That's actually how we measure the pH, right? You actually stick, there's a pH meter, obviously, right? This is a pH meter if you are in the lab, and then you put this pH meter inside your solution and it reads the pH. And according to pH, right, you tell whether it's an acidic or basic. This is the one way of knowing the acidity. And sometimes we use pH papers. Yeah, that's about pH. So I'm going to hold on to this, guys. So I'm not going to assign this to you. Or maybe
We still have
we
the
can
one due today, right, Dal?
Yes.
say it again.
We still have lab 1 that's due today.
Yeah.
Yeah.
Oh, yeah. Was that question? Was that? I thought you were questioning for the next lab. Okay.
No. This is our lab that's due today.
Oh, I see. Okay, I got the wrong answer then. Okay, let me just open the first lab then. Yeah, my bad.
Professor, did you look at those scales at the bottom, like from my email?
Yeah, I didn't check it, but I didn't get any complaint actually. But yeah, I will check it.
Okay.
Let me see.
Yeah, because I was following the instructions and I was getting densities that were not like, I was checking them like from Google after I did it and it was off. But then I realized that those scales, you have to zero the scales at the bottom to get the correct initial volume.
Okay, let me see. I mean, to be honest, guys, I didn't try this lab by myself. These are all virtual labs, but yeah, let me.
Let's do it together.
Yeah, they like they changed this laptops a couple times because since they are it turns out like some of them were not active anymore, and they play around again. Yeah. Okay, so you have this nice balance, right? So it says that you'll okay. Yeah, I mean, if you go through, right, you will you will do the lab. I mean, I don't understand like what's the like here. What we are doing here is right. You can find the density, right? You are trying to find the density uh, of the metal, right? Or whatever the subject that you have. So how can you find the density of water? I mean, density of the any matter is where is the web page? Right? You can find the water displacement, correct? So what you are doing here is let's take gold for instance, right? Drop the weight in the scale. Where's the so this is your gold, right? You are first putting this, and then you're reading, right? So it's 40 gram, right? Everybody's there, right? Hello? Okay.
Yes, we're here,
So
Professor.
okay, so now you know the density. I mean, let's go here. Let's go to clean page. Yeah. So how can you find the density, right? Density is equal to mass over volume, correct?
I guess.
So
Yeah.
mass is again, we usually write in grams, and then volume is in milliliters. Okay, you can write it in centimeter cube. It doesn't really matter, but this is the most common unit that we use, right? Gram and then gram per milliliters. So you need to find the mass and you need to find the volume. So let's take a look at this one. So for this one, the gold is, what's the mass? 40.53 grams. So I know the mass, okay, 40.53 grams. And now I need to find the volume, okay? Again, if it's an irregular shape, if it's a regular cylinder, you can calculate it, right? If you have a ruler, you can measure the right? You can measure the diameter, and then you can calculate the area. Area times the height is going to give you the volume. But if it's an irregular shape, then you can actually use a water displacement technique. So now you can actually bring this down. So what's the graduated cylinder that you are reading right now?
25.5.
Milliliters.
25.5, okay? Yeah, I think, Timothy, you don't need to bring this down to whatever the level it says, okay? Let's try 25.5, okay? So that's my initial volume, okay? Let's write it down. So initial volume, right? V initial, 25.5, right?
Yes.
So whenever I put this metal inside, whoops, right? So as you can see, the volume change, right?
Yes.
Okay, what's the volume right now?
27.6.
0.6, right? So what is this telling you then? 20 point, what was the volume again?
27.6.
27.6.
Okay, see, this is how much you displaced. What is this volume is telling you,
2.1 milliliters.
right? So like, what's the volume? Where is this volume coming from?
Because when you add in the gold, the volume goes up.
Yeah, I mean, this is the volume of the metal, right? Makes sense, right?
Okay.
You understand what I'm saying, right? So it's going to be 40.53 gram divided by, if you subtract this, 25.5.
So it's going to
Let's
be
do the math together.
2.1.
I know my math is not as good as yours, but
2.1.
2.5, there you go, milliliters.
2.1
So if you
milliliters.
divide this to 2.1 milliliters, then you're going to find your density. Make sense? Again, the numbers might be a little off, but it's okay, guys. Again, this is just showing you how to find the density of irregular shape, okay? And you can apply this to everything basically, right? Then imagine you have a rock, right? It's irregular shape, and if you know the initial volume, and if you know the final volume, then you can find the volume. Make sense?
Mm-hmm.
So you don't have to. I think, Timothy, your question was, does the instruction is saying bring this to a certain point?
No, the thing was, like, the instructions actually say click that turn fluid into water thing at the top. And so what happens when you do that is that that bar, I think there's a couple bars that maybe not, I don't know, but
Yeah,
I was getting like the wrong initial volume. So
I
the
see.
initial volume should always be 25.5 for all
Oh,
the
I see.
experiments,
I see. Maybe,
right?
yeah, maybe. I
Yeah.
mean, again, initial volume doesn't matter, Timothy. Again, here, it doesn't really matter what the initial
Yeah,
volume is. It can be 10, it can be 15, it can be 2. Doesn't really matter.
right. It's the difference.
Yeah,
Yeah.
it's the differences. So
Yeah.
again, when you add this gold here, now it changes, and the differences is going to give you the volume of your material.
Okay, I got it.
Make sense?
Thank you.
Mhm. Again, take it out. Yeah, it's fun actually. I like it. I should let play this, and then you
So
can change. Obviously, if you change the metals, now you're reading. See, this is actually, this was gold. Now this is lead. See that? So now, if you do this, the weight is different, the mass is different, and when you put this in, the volume is going to be different, and therefore the density is going to be different. Make sense?
okay. So
Okay.
you divided the volume of water and divide it from the mass in grams.
No,
You get
you
your
divide
milliliters.
mass over volume. It's
Okay.
mass over volume.
Okay. Yes.
And then make sure to put your units, because sometimes the student they don't put any units. But again, when it density, right? Whenever we are doing density, it's always gram per milliliter. You don't have to say GR. Actually, it's just G. Sorry, my bad. It's actually, let's write just. It's actually gram per milliliter. This is the right way.
Yeah.
Okay. Mass over volume. Mass over volume. That's your density. See, you can find your own density. You know, if you have a pool, imagine with a graduated cylinder, right? If you know how much volume do you have, and then you jump in the pool, and then you measure the differences, and you know your mass, and then you can compare. That will be fun. All right, makes sense, right?
Like mud.
Like mud.
I have a question, Professor.
Sure.
When would you grade the ones that we did already? Like if we handed this?
Yeah, I will
back?
probably grade like this week. I will just, you know, it wouldn't be so too long, guys. I'm really, I don't like to like grade at the last minute, so you should have it back probably like in a week.
Okay, thank you.
Well,
All right. So, all right then. So I'm not gonna start the new chapter today. It's almost 9:30. I think we did pretty good, and I'm feeling comfortable. And so I'm gonna publish the quizzes then for this chapter. Okay. And so you will have a week to finish it, and then next week we'll start a new chapter.
Okay,
the
sounds good.
next chapter might be a little short, so therefore I might be actually starting a new chapter, but we are not going to finish that chapter. But yeah, we'll figure out. Don't worry about it. I don't want to
Okay.
mix you guys up now.
yeah, that's easy to do for me.
All right. So, did someone ask a question? Did I hear something? Let's stop recording this because we're just. I think I see a chat question.